Hello guys, welcome to another video. This one is paper 1. It's the specimen paper 1 of Math of 2020. Okay, let's move on to question number 1. So here we have the polynomial p of x is equal to 2x cubed minus 3x squared plus qx plus 56 has a factor of x minus 2. So what does it mean? It means that if you put x in this equation as 2, it will become 0. This is what it means. So we have to use this to find q equal to 30. So let's do that. Let's put x here. X equal to 2. So p of 2 becomes 2 times 2 power 3 minus 3 times 2 power 2 plus q 2 and 56. That should be equal to 0 because it is a factor of this polynomial. Now let's simplify. 2 power 3 minus 3 2 power 2 plus 56. That will be 60 plus 2q equal to 0. So 2q equal to minus 60. Q will be minus 30. This is shown as required. That is part 1. Now for part B, factorize p completely, hence state all the solutions of p this. So we have to factorize them. So to factorize them, we first have to find the factors of this polynomial. So we know the first factor is x minus 2. So we can do this by division. So let's take this space over here. We will have p of x, which is this. So q is minus 30 and plus 56. So let's do division. So this is factor x minus 2. So how do I get 2 here? So how do I get 2x cubed from this? We have to multiply by 2x squared. So multiply, you will have 2x cubed minus 4x squared. That's the first step. So this goes away. So minus 3 plus 4, that will be 1. So now we have x squared minus 30x plus 56. Now how do we obtain x squared from this? We have to multiply by x. So x becomes x squared minus 2x plus 56. So let's bring this over here. Simplify, we have this goes away. We have minus 30 minus 2 minus 2, that will be minus 28x plus 56. So now from this, how can we get minus 28? We have to times by minus 28. So it becomes minus 28x and then plus 56. This becomes 0. So this means that we have this part and this part. So now we have p of x is equal to x minus 2 times the top one, which is 2x squared plus x minus 28. So now we have to factorize this one. So 2x squared plus x minus 28 is equal to, so 2x squared is 2x times x. 28 has factors of 1 times 28, 2 times 14, we have 4 times 7. So how can we get plus 1? So we have to use this one. So 4 here and 7 here, plus 1, you will need to be plus 8 minus 7 for it to be plus 1. So now we have p of x equal to x minus 2, 2x minus 7, and x plus 4. Equate this to 0, solve. So x equal to 2, x equal to 7 over 2, and x equal to minus 4. So you have 3 solutions for this equation. That will be number 2. Variables y, x, and y are related by this equation. So what is this? This is y equal to x times x power half, which is x 3 over 2. So find dy by dx, so pretty easy. I'll do 3 by 2 and 3 by 2 minus 1, which will be 3 over 2 square root of x. That will be dy by dx. Now for part B, hence find the approximate change in x when y increases from 8 by a small amount of 0.015. So this here it's y. So we have to find the value of x. How much does x increase? From which value? So y will be so y is x this. So this is 8. So x is 3 over 2. This will give me x will be 8 2 over 3. That will be 4. So basically we have to replace in this equation for x dy by dx when x equal to 4. That will be 3 2 4. That will be 3. So now if you want to find this one, the approximate change, you just have to be careful, because as you see here, this is y changes by this much, it's not x, so it means that this 0.015 should be over change of x approximately equal to 3. So change in x should be equal to, approximate will be 0.015 divided by 3. That will be 0.005. So this will be your answer for the approximate change in x. That is question number 2. To question number 3, part A. Express this 12x squared minus 6x plus 5 in the form of this. So when you see this, you must know that we are actually trying to complete the square for this equation. So first thing to check if the coefficient of x squared is 1. Here it is 12, so we have to take it out. So 12 outside, we have x squared minus 1 over 2 x. So we could just leave the 5 outside for now and look at this. So we have, let's look at the inside first, so which is this, right? So we have to convert this to a square form. How do we do this? So we need to look at this number. So we need to add this number here, which is half, divide by 2 square. Now if you add something, you have to minus the same number, so it is the same numbers, right? If that makes sense. Now let's simplify this. So this thing here becomes, we have x minus, and this number, so 1 over 2 divided by 2, that is 1 over 4, and we'll have this. So this one stays here, 1 over 4 square, and then now we put this one back in this, so we will have 12 plus 5. So let's simplify and expand. So this one will be, let's bring this in, we'll have 12 x 1 over 4 power 2 minus 12, now we 1 over 16 plus 5. So let's simplify. What is 12 over 16 plus 5? Minus 12 over 16 plus 5, that should give me 4. So we'll have 12 x 1 over 4 square plus 414. So 414 is just, so let's write this in this form. So 17 over 4. So it will be in the form of this, which is, this is p, this is x minus q square plus r. As you can see, we have the answer right here. Now moving on to part B. Hence find the greatest value of inverse. So let's say, first let's write down this equation, 12x this square plus 17 over 4. Let's say we had this at first, right? So for this equation, what is the max value? The max value for this one, it will be this value here, it will be 17 over 4 at x equal to 1 over 4. So same way, for this one, for the inverse of this function, so inverse of 12. So similarly, for the inverse, the max value will become, we have to flip it for the inverse value, and the value of x will be the same. So this is your answer here. Max value will be 4 over 17, value of x will be this much. So that will be question number 3. Question number 4, do not use a calculator in this question. So that is very important. You have to show all your working. That's what it means basically. Now, the diagram shows a trapezium A, B, C, and D, in which AD is 7. We have AB as this value, and AX is perpendicular to DC. So we have this and this. So what is the length of DC? It will be x plus 2. This is 2, this is x. I hope that makes sense. Now, given that the area of the trapezium is this much, obtain an expression in terms of x, so x, 4x, in the form of this. So basically, we have to find the area of this trapezium. We know this is the area, but how do we find the area? So let's write down the formula. Area of trapezium is equal to half times sum of parallel sides. So the sum of the sides, and times the perpendicular height, which is this one. So we don't know this one. How do you find the height? As you can see, we have a right angle triangle. We know this side and this side. We can find this side. So the height here is ax, and the way we find this is by the Pythagoras Theorem. So we have 7 square minus 2 square is equal to ax square. So that will be 49 minus 4 equal to ax square. So ax equal to 45. This will bring you, square root of 45. That will be the height. So we have one part. So now let's replace in the equation. So we know the area is equal to what? 15 times square root of 5 plus 2 equal to half times sum of parallel sides will be this side plus this side. So this one is 4 plus square root of 5, and this one is x plus 2 plus x plus 2 times the height, which is square root of 45. So now what can we do? Is we can simplify. We can send this one over here. We will have 30 square root of 5 plus 2 equal to, so this one we can simplify as well. So what is square root of 45? It is square root of 9 times 5, which is 3 of 5. Hope that makes sense. So if you write this here, 3, 5, so that will be 6 plus this and plus x. So let's try to simplify. So 3, and this is 3, so 10 remains 1. Let's try to expand the bracket. So we have 10 square root of 5 plus 20 equal to 6 square root of 5 plus 5 plus x. So now let's make x the subject of formula. So x will be equal to, we send these on over here, we have 10 square root of 5 minus 6 square root of 5 plus 20 minus 5. So x is equal to 4 square root of 5 plus 15. And it says to give your answer in the form of a plus b square root of 5. So your answer is x is 15 plus 4 square root of 5. This will be your answer, and this is question number 4. Question number 5, part A. So on the axis below, sketch the graph of y modulus of 2x plus 5 and the graph of y equal to modulus of 2x minus 1, stating the coordinates of the points where each graph meets the axis. So let's look at one by one. So let's have a look. Let's use, so we'll need some space. Let me just try here. So on this side, let's look at the first one. The first one is y equal to modulus of 2x plus 5. Now, on the x-axis, y equal to 0. So x equal to minus 2.5, right? So that's the first point, minus 2.5 and 0. Now, on the y-axis, x equal to 0, so value of y will be 5. So we have 2 points for now. So we can first label the axis. So let's do that here. So here will be, so this one doesn't need to be exactly because it is only sketched, so it doesn't need to be exact the equation. So it can be a little bit, can be a little off, but that's okay as long as you show where it intersect the axis and the curve and the lines. It should be okay. So right now I just draw the axis and label the coordinates. So this will be 2, 4, 6, 8, minus 2, minus 4, minus 6, minus 8, 2, 4, 6, 8, 10, and then here we can have minus 1, minus 2, minus 2, minus 4, minus 6, minus 8, and minus 10. So for the first point, so as you must know that for modulus curve, graphs, it never goes below this line. It's always above. Anything that goes below, it reflects on this line. So make sure that you don't have anything that goes below the x-axis. That's a very important thing to know. So the first point will be minus 2.5, 0. So that's the first point. Will be about here. And then we have 0, 5. 0, 5 will be here. So this will be the first part of your graph for this one. So as you can see, it goes here. It will also go down. But of course, for modulus, it cannot be down. So let's find a point on this side to find another value on this side. So let's say if x equal to minus 6, y will be, so let's do that, minus 12 plus 5, that will be, it will be 7 because it will be minus 7 modulus, that will be 7. So minus 6, 7 will be between 6 and 8. Right here. So your graph for this one will be like this. Okay, that will be y equal to modulus of 2x plus 5. That's the first graph. And now let's move on to the other graph. So for this one, same steps, y equal to 2 minus x. So when x equal to 0, y equal to 2, and when y equal to 0, x equal to 2. So we have 1 point here and 1 point here. So let's just draw this one first. And then you see that it does go down, but of course for modulus curve it cannot be going down. So let's find something here. Let's say if x equal to 6, y will be minus 4, which is 4. So 6, 4 will be on this point here. So this will be on this. So this is your graph for y equal to 2x minus x, sorry, 2 minus x modulus, red one and the blue one. That will be enough for your 4 marks. Now moving on to part B. It is asking us to solve the equation. This is your graph. You have to find the values of x for which the first graph is less than the second graph. So where is it less than the second graph? You can see clearly that this is the first graph. It is less than the second one only at this point, between this and this point. So we have to find this and this. So from my graph I can see it should be -1 and -7. So I can either solve the graph simultaneously, or I can just solve this one. Pretty easy. The first thing I can do, let's rewrite this down as this to find the values of x. So what can we do to remove modulus on both sides? We can square both sides. We'll have 2x plus 5 square, 2 minus x square. Now we have 4x square plus, that will be 20x plus 25 equal to minus 4x plus x square. So we send this over here, we'll have 3x square plus 24x plus 21 equal to 0. So we can divide everywhere by 3. We will have x squared plus 7x, and so 24 will be 8 and 7. So now we have to factorize to find the values of x where they meet. So that will be 7 and 1 plus and plus. So x equal to -7, x equal to -1. So this is the 2 points where these two graphs meet. So on this graph, this is here -1 and this is -7. So the question here is asking you, where is this one less than the other one? So it is between this point and this point, which is between -1 and -7. So your answer will be, for x between -7 and -1. So this will be your answer for part B. And that is question number 5. Question number 6. Find the equation of the normal to the curve y equal to this fraction, where x equal to 2. So how do you find the equation of a line? Of a normal is a line. So we need to first find the gradient, and we have to find a point where it passes. So we know x is 2. What is the value of y? So we place x in this equation. We have what? So 2 times 2 minus 1, that will be 3. Divide by 3, that will be 1. So square root of 4 plus 5 is 9. So 3 over 3 is 1. So the line of normal passes to the point of 2, 1. So that's a good thing to have for now. So we have to understand what are we looking for. For example, let's say the curve y is in this shape. And at point x equal to 2, let's say it's here, and we have a tangent here, which represents the gradient of this point at x equal to 2. So now, equation of normal is equation of this line, of the red line. It passes this way to this point at 90 degrees. So we first have to find, so for us to be able to know the gradient of this line, we first have to find the gradient of the tangent, and then we can find the gradient of the normal. So for us to find this gradient, we have to know dy by dx. So let's do that. So let's find dy by dx for this equation. So first step, that will be the same, x squared plus 5 multiplied by dy by dx of this, that will give me 2 minus, and dy by dx of this one, that will be half x squared plus 5, that will be minus half, times 2x, divide by square of the bottom, that will become x squared plus 5. So simplify. So this goes away, this goes away. So what do we have next? So we have here 2 square root of x squared plus 5 minus 2x minus 1 over square root of x squared plus 5 divided by x squared plus 5. So if you want to, you can simplify, but you don't need to, because you only want to find the value of dy by dx at x equal to 2. So let's just do that. Let's replace. at x equal to 2. So for the first one, that will be 2 power 2 is 4 plus 5 is 9. So 2 times square root of 9 is 2 times 3. Now, minus the top will be 2 times 2 is 4 minus 1 is 3. Divide by 3, same thing, 3. And this whole thing divide by, this is 2 square, that will be 9. So simplify, this will give me 6 minus 1 divided by 9. This will be 5 over 9. So dy by dx at this is 5 over 9, which is the gradient of the tangent is 5 over 9. So from this we know gradient of normal will be minus 9 over 5. So this is the first step. So now pretty easy now. If you want to find the equation of a line, if you know the point it goes the point through 1, and we know the gradient, so we can find the equation pretty easily. So the point is 2, 1. We call this one x and y. So equation will be y minus 1 over x minus 2 equal to minus 9 over 5. So now we cross multiply, we will have 5y minus 5 equal to minus 9x plus 18. So simplify, 5y equal to minus 9x plus 18 plus 5. So 5y becomes minus 9x. This will be plus 23. So now we need to express this equation in the form of ax plus by equal to c. So we need to send x over here. So the answer will be 9x plus 5y equal to 23. This will be the equation of the normal. That will be question number 6. Question number 7. The diagram shows a badge made of thin sheet of metal. That's the badge given to you, consisting of 2 semicircles. So semicircle here and here on top. They are joined by a rectangular piece. So joined by this. So now we know the radius is x. So radius is x of the semicircles. So this is y. That's good. And then part 1. Given that the area of the badge is 20 cm square, show that the perimeter P is given by this. So when we have some information here in the beginning, we have to use this information. It says the area of the badge is this much. So first let's try to find the area. How would you find the area of this shape? It will be area of this semicircle plus this semicircle and the rectangle. So one by one, right? So since these two are the same, let's call it this one, let's call area of S for semicircle. So these two are same, so that will be 2s plus rectangle. So let's find that. What is the area of the rectangle? It will be length times width xy plus what is the area of the semicircle? So you do know that the area of a circle is pi r square. Semi will be divided by 2. So it will be 2 times pi r is radius is x square divided by 2. Simplify, that will be pi x square plus xy should be equal to 20 given to you. So that's the first equation that we have from the area. So just for now, in case we need it. So now we have to find the perimeter of the badge. So we have to find this distance around the badge. So one by one. So what is, this is x. This is x as well. What is this distance? The arc of the circle. This is y here. So y, y, x, x, and this one and this one. So let's find the arc of the circle. So that will be, usually we'll have 2 arcs. So 1 arc here and 2 arc here. So 2 arc plus, this one is x, this one is y, and plus x, and then we have this already, so we have the plus y. So let's find the value for the arc. So for the full circle, it's by the formula 2 pi r. Now for the semicircle, it will be divided by 2. So replace in the equation, we have 2 times 2 pi r, our radius is x, divided by 2. Now simplify, that will be 2x plus 2y. That will be 2 cancel. You'll have 2 pi x plus 2 xy. So now you have to show that this is p. You have to show that p equal to 2x plus 40 over x. So from the first equation here, we have something. We can write this down over here and compare. So what do you find in both of the equations? So you see we have pi here and pi here, and we don't have pi in this equation. So what can we do? We can make pi the subject of formula. So pi is equal to 20 minus xy divided by x squared. So replace pi in p. 2 times pi will be 20 minus xy divided by x squared times x plus 2x plus 2y. So this will be gone, and this is 1. And let's simplify. So we have 40 minus 2xy over x plus 2x plus 2y. Now we have simplify 40 divided by x, that will be minus 2y plus 2x plus 2y. So minus 2y goes away. So p equal to 40 over x plus 2x. So you can write this same as the above, which is 2x plus 40 over x. So 2x, this is shown as required. That will be part A of question 7. Moving on to part B. Given that x can vary, find the minimum value of p. So what we need to find is, so since we know the p is equal to 2x plus 40 over x, which is also 2x plus 40 x minus 1. So we need to find the minimum value. So we know that at minimum value, dp by dx needs to be equal to 0. So we have to find dp by dx. So let's do that. dp by dx equal to 2 minus 40 x minus 2, which is 2 minus 40 over x squared. So this is equal to 0. Solve for the value of x. So times x everywhere, we will have 2x squared minus 40 equal to 0. This will be 2x squared equal to 40. So x squared will be 20. So x will be 20. So since the x is the radius, it cannot be negative, so it can be 20. So square root of 20 will be the value of x at this. So the p, the value, minimum value of p will be 2 times x plus 40 over x. Let's simplify. 2 square root of 20 plus 40 divided by square root of 20. That will be 17.9. That's the value of p, centimeter. Now justify why it is a minimum value. So to find if it is a minimum value, we have to find d2p and dx2. So let's find that. So we know dp by dx is this, so we have to differentiate one more time to find this. So that will be 0 plus 80 x minus 3. So that will be 80 over x cubed. So since this is positive, it can only be, the value here can only be more than 0. So you would say, since d2p by dx2 is more than 0, the value p is a minimum. That will be question number 7. Number 8, giving your answer in its simplest form, find the exact value of the first one. So you have to integrate this exponential. Pretty easy. So how do you integrate exponential? It becomes the same. Divide by integration of 5x minus 1. So that will be actually divided by 5. So that will be your value, and the range is 1 to 0.2. Replace, we have 5 minus 1 over 5 minus e times, that will be 1 minus 1 over 5. Factorize this out, you will have e power 4 minus e power 0, which is e minus 1 over 5. This will be your answer for part 1. Now for part 2, integrate this equation. So let's make it easy for you. We can first expand this to make it easy. This is actually x squared plus 2x 1 over x squared plus 1 over x cubed, fourth. So that is equal to what? Goes away. That will be x squared plus 2x minus 1 plus x minus 4. So let's integrate 2(1) of x squared plus 2x minus 1 plus x minus 4 dx. So x squared will be x power 3. That will be over 3 plus. So when we have 2x minus 1, it is 2 over x. And integration of this will be 2 ln x. So 2 ln x plus this will be x minus 3 divided by minus 3. Simplify 2, 1. So 2 will be 8 over 3 plus 2 ln 2 plus, it become minus x power of, sorry, x is 2, power of minus 3 over 3 minus 1 now. That will be 1 over 3 plus 2 ln 1. ln 1 is usually 0. Let's check. Yep, 0. So this is 0 plus that will be 1 over minus 3. So simplify. What do we have here? So 2 power of minus 3 is 1 over 8 divided by 3. That will be 1 over 24. So 8 over 3 minus 1 over 24 will be 258 will be 2 times 8 is 16 plus 5. That will be 21 over 8 plus 2 ln 2 minus, so 1 over 3 minus 1 over 3, this is 0. So your answer will be basically this, 21 over 8 plus 2 ln 2. If you want to take this out, you can always do 1 over 8 outside. You will have 21 plus 16 ln 2 if you want to, but this is enough for your answer. Now for part B, find this one. So what is sine x over 6? It is basically sine 6 times x. So integrate of this, you will have sine 1 over 6 times x dx. So pretty easy. You have to integrate this sine. It will give you cos, now minus cos 1 over 6 x divided by 1 over 6 plus c. Simplify, you will have minus 6 cos 1 over 6x plus c. And this will be your answer for part B. And that is question number 8. Question number 9. Do not use a calculator in this question. So in the expansion of this, the coefficient of x power 4 is 10 times the coefficient of x power 2. So we just need to find those two coefficients from this. So we have 1 plus 2x power n. So first one, coefficient of, let's say, x squared. Let's find that. So we will have to n choose 2, 1n minus 2 times 2x power 2. That will give you n choose 2. This is 1. This is 4x squared. So the coefficient of x squared is this. N choose 2 times 1 times 4. So now we have to know what is n choose 2. So n choose r, for example, you will see that from the page of your formula here, it will be equal to n factorial divided by n minus r factorial times r factorial. So same thing here. If you replace this here, we will have n factorial divided by n minus 2 factorial times 2 factorial times 4x squared. So this is your coefficient of x squared. So you can also simplify this, as you can see. This is what? So let's write this down. So n factorial divided by n minus 2 factorial is actually equal to n minus 1. I hope you can understand this. If not, then I will show you this in a bit. This is 2. So 2 go away, 2 remaining. That should be the coefficient of 2. So how do I get this from this? So let me write this on this side. For example, let's replace this value here. Let's say if n equal to 4. So that will be what? 4 times 3 times 2 times 1, right? Now, this is n minus 2. This will be 2. What is 2? 2 is 2 times 1. So if you divide this 2, you can cancel the tail, as you can see. So basically what's happening here, it is 4 times 3 times 2 factorial. So that's why you can cancel this from here, and remaining will be 4 times 3, which is n times n minus 1. I hope that makes sense. That's why I have this here. So that will be the coefficient of x squared. Now for part 2, coefficient of x power 4. So that will be n choose 4, 1, n minus 4 times 2x power 4. So n choose 4 power 1 times 1, sorry, and then this one will be 2 power 4 x power 4. So this one here will be n factorial divided by n minus 2 factorial, sorry, minus 4 actually, and 4 factorial. That will be 16 hex this. Simplify. So this over this will be equal to, so just like this one, we use the same method. It will give me n times n minus 1 minus 2 and minus 3. For the rest, it will go away. Okay, so this will become 4 factorial is 24 times 16 x power 4. So this is the expansion of this term. So let's find the ratio. So 16 over 24 is 2 over 3. So we have 2 over 3 and minus 1 minus 2 and minus 3 x power 4. So now we have to use this part and this information. It says the coefficient of x power 4 is 10 times this of x squared. So use this and this. So it says that this one, 2 over 3 with n minus 1, n minus 2, and n minus 3 is equal to 10 times of the first one. So let's simplify. So this one goes away, and so this is 1. The top here is 1. So this one goes away as well. So remaining will be, this one goes away. it will be n minus 2, n minus 3 equal to 30. So simplify, we will have n squared minus 3n minus 2n plus 6 equal to 30. So n squared minus 5n plus 6 equal to 30. So we bring 30 over here, we'll have n squared minus 5n minus 24 equal to 0. So factorize. N squared is n times n, and this is 8 times 3, so 8 and 3 minus 8 plus 3, 0. So basically n can be 8 or n can be minus 3. So it cannot be minus 3 because n is a positive integer, n. So your value of n will be equal to 8. This is your answer for question number 9. 10, part A, we have an arithmetic progression has the first term, which is a, equal to 5, and a common difference of minus 3, so d equal to minus 3. Now, find the number of terms such that the sum to n terms is first less than minus 200. So here we can use the formula given to us on the page of the paper, first page. So here we have geometric and here we have arithmetic. So the sum to n term is given by this equation. So let's write this down here. So sum to n terms is equal to half n times 2a plus n minus 1 d. This is given to us on the page of the question, on the question paper. So now we want to know that what is n when it is first less than 200. So we want to know when is first less than minus 200. So let's do that. Half n, that will be 2 times a, which is 5, plus n minus 1, d is minus 3, less than minus 200. So let's simplify. Let's send this one over here. We will have, so n here is 10 minus 3n plus 3 less than minus 400. That will be minus 3n plus 13 less than minus 400. So here we have minus 3n squared plus 13n less than 400. So we can do this one. Plus 400 less than 0. So we can solve this and find the value of n. So let's say a equal to b equal to 13 and c equal to 400. So value of n will be minus b plus minus. So let's use our calculator here. B squared minus 4 times a times c. That will be square root of 4969 divided by minus 6. Now value of n. So first value, let's do minus 13 minus square root of 4969 divided by minus 6. That will give me 13.9, or the other one will be minus 13 plus 4969 divided by minus 6, minus 9.58. So in this case, we can only have this one because it cannot be negative. So this one. So basically what it means is that n needs to be at least bigger than this for it to be first less than minus 200. So n will be, the first integer after this will be 14. So this will be your value for n. Now moving on to part B. A geometric progression is such that its third term is equal to this and its fifth term is equal to this. So again, from the question paper, we have formula here for geometric series, this is a term. So u of n equal to ar n minus 1. So this is a term, u of n ar n minus 1. So from this we can know that the third term is u of 3, which is ar squared equal to 81 over 64. Now this one is fifth term, which is u of 5 will be a of 4 equal to 729 by 1024. So from this we can find the value of r squared. So we do a of 4 squared divided by a of r squared. That will be r squared equal to what? A of 4 squared is 729 over 1024 divided by 81 over 64. That will be 9 over 6. So r will be 3 over 4. That's the value of the common ratio r. Now we have to find the first term, which is a, value of a. So we have to use this one here. So we know that r is this, r squared is 9 over 16. So a 9 over 16 equal to 81 over 64. So a is what? 81 over 64 divided by 9 over 16. That should give me 2.25. That's the value of a. Okay, now moving on to part 2 for this question B. It says, hence find the sum to infinity of this progression. So here, same thing as well. We have the formula given to us. So sum to infinity, if r is less than 1, will be this. So let's check. The value of r that we have is 9 over 16, so it is less than 1. So good. So we can use this formula. So sum to infinity equal to a over 1 minus r, which is a. A we have found it will be, it was 2.25, 1 minus 9 over 16. So let's do that. 2.25 divided by 1 minus 9 over 16. That will be. So let's try again. Sorry, r is actually, this is r squared, mistake. R is 3 over 4. It's still less than 1. So we replace 3 over 4 here. So 2.25 divided by 1 minus 3 over 4. That will be 9. So this is your answer for part 2, and that was question number 10. Number 11. So we have a graph of y. It cuts the y-axis at point A, and the graph of this y and this line intersect at point A and point B, as you can see here, right? Now we say the line BC is perpendicular to the x-axis. Now we have to find the area of this region enclosed by the curve and the line AB. So basically we have to find area of this shape minus area under curve to find this area. So let's call this area. So this big area ABCO is area of trapezium. I hope you can see that. These two sides are parallel in the same direction, and we have this two. So it is area of trapezium minus area under curve to find this area. So let's do one by one. So first thing we need to do is to find these points. So what is the point A and point B? So it says that this equation, it goes through this point. Point A is at the y-axis, which is x equal to 0. If x equal to 0, y is 10. So this is 10. So we have 0, 10. That's the point A. Now for point B, intersection of this line and the curve. So we have to solve to find the point B. So let's do that. So the line is this and the curve is this. So we have equation. Simultaneous equation will be this minus 4x plus 10. So now let's solve. Bring this over here. Will become minus 5x, and this will cancel out. So factorize x outside. X minus 5 equal to 0. So first one is x 0, x equal to 5. So this we know already, x0 is 10, so 5 will be y equal to 15. So point B here is 5, 15. So basically what do we know is that this point is 0, this point here, this line here is 5, and the height here is 15, and the height here is 10. So from this information, this is the length of 5. So from this information we can find the area of the trapezium. So first step, area of trapezium ABCO. So we do have times sum of both sides, that will be 10 plus 15, and times length in between, that will be 5. So let's do that. Half times 25 times 5, that will be 62.5 units square. That is area of trapezium. So now you have to find area under this curve, so we can minus that area to find this area. So we have these 2 points already. This is x0 and x equal to 5. So we have to integrate part 2. We have to find area under curve, curve of y equal to x squared minus 4x plus 10. So integration of 5, 0 of x squared minus 4x plus 10 dy by dx. So dy, that will be x3 over 3 minus 2x squared plus 10x between the range of 5 to 0. Now let's simplify. We will have 5 power 3, so 125 over 3 minus, so 525, that will be 50 plus 50. That's the first part, minus 0. So this goes away. We'll have 125 over 3 for area under curve. That will be units square. So area of shaded region will be area of trapezium minus area under curve. So 62.5 minus 125 over 3, that should give you 25 over 6 units square. This will be your answer for question number 11.